So here I'll discuss exercise 5B of Lee-Peng-Yee additional mathematics book, question number 24. Okay, so this is the diagram of a trapezium actually. All right, so A, B, C, D. So, and you see that DC and BC, they're actually perpendicular, and DC and AB, they're parallel to each other. They're parallel to each other. Okay, and the coordinates are given. And the coordinates of A, B, and D are given. Okay. So in part A, they're asking for find the equation of DC and BC. So let's look at DC first. You have to find the equation of DC. So I do have a point. In order to find the equation of a line, I need a point. So that point D, one point is there, but I don't know the equation. I don't know the coordinates of C. Okay, but I do know that DC and AB are parallel to each other. So the gradient of AB is same as the gradient of DC. Gradient of AB is same as the gradient of DC. So what is the gradient of AB? I can write it in short like this. Gradient of AB is equal to gradient of DC. So what is that? You can just do y2 minus y1 by x2 minus x1. So this comes as half. So you know the gradient of DC and you know a point. So I'll just apply like y minus y1 equals to m into x minus x1. So I'm using the coordinates of D. This, if I want, I can simplify by multiplying both sides by 2, and then I'm going to get 2y is equal to x plus 15. 2y is equal to x plus 15. Okay. All right. So this is the equation of CD. Now they're asking for find the CD or DC, same thing. They're asking for, so you have to find the equation of BC. So BC, again, I know the point B. I know the coordinates of the point B, but what will be the gradient of BC? So gradient of BC is perpendicular to CD and AB. So the gradient of AB is half. So the gradient of BC is going to be the negative reciprocal of that. So it's going to be minus 2. It's going to be minus 2. The negative reciprocal of half, or minus 2 into 2, minus 2 into half, you see that it comes as minus 1. Okay. So I just do the reciprocal and then multiply by minus 1. So that's the gradient of BC. So what is the equation of BC? So I'll use the point B. I'll use the point coordinates of B. Okay. So now if I simplify, it's going to be y is equal to minus 2x plus 40. So this is the equation of BC. This is the equation of DC. This is part A. So what they're asking for in part B, what they're asking for in part B. So find the coordinates of point C. Find the coordinates of point C. So C is basically what? C is the point where the line DC and BC intersect. C is the point where the lines DC and BC intersect. So you have to basically solve simultaneously the equation of DC and the equation of BC. That will give you the point of intersection of these two lines, which is actually C. So I can just easily substitute like y is equal to minus 2x plus 40. So over here, instead of y, I can just write minus 2x plus 40 is equal to x plus 15. Okay. So if I solve it, actually, I'll get the coordinates of C. I get the x coordinate, then the x coordinate I can apply, I can insert here to find the y coordinate also. This is quite easy. So you get the x coordinate as 13. And if you apply if you write the insert the x coordinate over here, you get the y coordinate as 14. Okay. So this is the coordinates of C. So our part A and B is done. Part A and B of 24 is done. Part C, they're asking for the coordinates of point P. They're asking for the coordinates of point P. So what is P? P they have defined as, like, if I extend AD and BC, they'll meet at a certain point. So that they have labeled as P. This is P. Just by extending AD and BC. Okay. Extending AD and BC. So now you have to find the coordinates of P. You have to find the coordinates of P. So coordinates of P basically what? Where P is basically where line BC and AD intersect. So basically what? You have to solve simultaneously the equation of BC and the equation of AD. So you already have found out before the equation of BC. So now you have to find the equation of AD. You have to find the equation of AD. So gradient of AD is 8. And there are 2 points actually. You know the coordinates of A, we also know the coordinates of D. So you have to use any other of the points. Use any of the 2 points and you'll get the same answer. You get the same answer. Here I'm using the coordinates of A. So y minus 2 is equal to 8 into x minus 4. So this is y is equal to 8x minus 30. That is what you're going to get. And we had the equation of BC previously. That is the equation of AD. Previously, we had the equation of BC also. We had found it out. That is y is equal to minus 2x plus 1. So basically, you can find the value of x very easily. That is, to solving simultaneously, just write 8x minus 30 is equal to minus 2x plus 40. Okay, 8x minus 30 is equal to minus 2x plus 40. Find the value of x. And then insert the value of x over here or over here to find the value of y. That is the y coordinate of P. So what do you get as the x coordinate? The x coordinate will come as 7. The x coordinate is going to come as 7. Or it's just like this. 8x minus 30 is equal to minus 2x plus 40. So you get basically 10x is equal to 70. So x equal to 7. And the value of, so 7 you insert over here or over here, you get the value of y coordinate as 26. You get the y coordinate as 26. All right. So this is part C. There's the coordinates of P, which is just the simultaneously you have to solve the equation of AD and the equation of BC. Equation of AD we just found out, and equation of BC we had found out before also. Now in part D, they're asking for the ratio of AP is to DP. They're asking for the ratio of AP is to DP. Ratio of AP is to DP. So now we have all the coordinates. So it's not a big deal actually, because I can find the length of AP. Okay. Root x2 minus x1 whole square plus y2 minus y1 whole square. That formula. If I do that, so I get actually root 585. I can keep it just like this. AP and DP. If I find it out, root 260. So AP is to DP. If I divide, I get 3 by 2. So AP is to DP, it is 3 to 2. Just dividing this, I get 3 by 2. So AP is to DP, it is 3 to 2. 3 to 2. That's the answer of part D. That's the answer of part D. The next part, they're asking the ratio of area of PCD to the area of trapezium ABCD. Okay, to the area of trapezium ABCD. So since we know all the coordinates that are included here, that is P, C, D, A, B, C, D, all the coordinates we know. So basically, one easy way to do this is to find the area of triangle PCD. You can just use the shoestring method. Then area of triangle, area of trapezium ABCD which you can easily find using the shoestring method. And then you divide by, so you just divide. So you'll get the ratio. In that way, you're going to get the ratio. But here, since we have already found out AP is to DP, so we can actually use that answer to find the ratio. So you don't need to do the, you don't need to find the individual areas. So one very smart, not smart way, but actually if you are not, you can actually do that if you're not able to figure it out. If you're not able to use this answer. But actually in the question, I sense that that is what they would actually like you to do. Use the previous answer, not to find the individual areas. But if it doesn't come to your mind, finding the individual areas using the shoestring method is actually a very good idea. Okay, so PCD, you know that coordinates, so you find the area using the shoestring method, and the trapezium also, the area you can find out using the shoestring method. Then you just divide. Then you simply divide. Okay, then you get the ratio. You get the ratio. If you help with the shoestring method, you can actually one approach is to, you can look up in the course book. It is not given in LeePengYee, I think. So you have to look up in the course book, additional mathematics course book, the other textbook that we follow. So in that book, in page 149, it is actually done. In page 149. Okay, and also you can search even Google also if you want. Now, how to do it without finding the individual areas? So AP is to DP, it is 3:2. AP is to DP, it is 3:2. So if A, okay, so AP is to DP, it is 3:2. So what is the ratio of so basically what you have to understand, that there are these two triangles, that is the triangle PCD and triangle, there's a smaller triangle and the larger triangle, and triangle PBA. Similar, they're actually similar triangles. They're actually similar triangles. Okay, so now so basically AP is to DP is 3:2. So if I take the corresponding sides like DP, that is over here, DP and AP, they're actually corresponding sides of the similar triangles. DP is of the smaller triangle, AP is of the larger triangle. So AP is to DP, AP by DP, it is actually what? It is 2/3. It is 2/3. That's the ratio of the corresponding side. So the ratio of the areas, it is going to be what? So the ratio of the corresponding sides, it is 2/3. It is 2/3. So what is going to be the ratio of the similar triangles like this and this? It's going to be 2/3 whole square. It is going to be 2/3 whole square, which is 4/9. Which is 4/9. That is the ratio of the sides. AP is to DP, or I'm just doing DP is to AP. So it is 2:3 instead of like the smaller one by larger one. So it is 2/3 AP by DP. So since they're similar triangles, because these two sides are parallel, so the ratio of the area is going to be 4/9. The ratio of the area is going to be 4/9. So what happens here now? So if the ratio of the this triangle and the larger triangle, it is 4/9. That means what? If the smaller triangle has area 4x, let's say, I can just write 4 also for like if you find it easy. But let's say it is 4x. Let's say the area of the smaller triangle is 4x. Then the area of the larger triangle, it will be what? It will be 9x. So if this 4:9, the ratio of the smaller triangle and the area of the larger triangle. So the area is 4:9, ratio of the area. So if this is area of the smaller triangle is 4x, area of the larger triangle is 9x. So what is the area of the trapezium basically? Area of the larger triangle minus area of the smaller triangle. Area of the larger triangle minus area of the smaller triangle. So the area of the trapezium is simply going to be 9x minus 4x. Area of the larger triangle minus area of the smaller triangle, 5x. So what you have to find out here is that area of PCD to the ratio of the area of the trapezium ABCD. So this is just 9x minus 4x. So this is 5x. So so the ratio, this ratio that they're asking for is going to be 4x is to 5x. So it is 4:5. It is going to be 4:5. That is 4x, total is 9x. Smaller triangle 4x, larger triangle 9x. So trapezium is basically what? Larger triangle minus smaller triangle. So this is going to be 5x. So the ratio is going to be what? 4:5. So ratio of the larger triangle is to the smaller triangle, ratio of the area of the smaller triangle to the trapezium, that is the area of PCD to the area of trapezium ABCD, is going to be 4:5. Smaller triangle to the trapezium, which is larger triangle minus smaller triangle. The area of the trapezium is simply the area of the larger triangle minus the smaller triangle.